Namaskaram, Vanakkam, Ashamkal. I welcome you all for the today's video. In this video, we'll be doing a wonderful experiment, that is ID curve experiment through a glass prism. That is refractive index of a given prism using ID curve. So friends, before doing the experiments, let's have a look at the aim of the experiment. The aim is to find refractive index of a given prism by using ID curve. So the apparatus required for this experiment are drawing board, triangular glass prism, pencil and scale, pins, protractor and a drawing sheet. So now let's have a look about what's the theory behind this experiment. First of all, what is a prism? A prism is a three-dimensional solid object in which the two ends are identical. It is a combination of flat faces, identical bases and equal cross sections. And a triangular glass prism is a transparent object made of glass having two triangular bases and three rectangular lateral surfaces. So, angle of prism. It is the angle between two surfaces. It is also known as refracting angle. In a prism, a ray of light suffers to refraction and the result is deviation. After passing through prism, the ray of light deviates to a certain angle from its original path. Now, angle of incidence. The deviation angle depends on the angle that the beam enters the object and it is called the angle of incidence. Refraction is due to the change in speed of light while passing through a medium and it is given by Snell's law. That says n1 by n2 is equal to sin theta 2 by sin theta 1, where theta 2 is the angle of incidence and theta 1 is the angle of refraction. The refractive index can be calculated by the given equation, that is mu is equal to sin a plus dm by 2 by sin a by 2, where a is the angle of prism and dm is the minimum deviation. Now let's know how to do this experiment. First of all, to determine the angle of prism, place a drawing sheet on a drawing board and secure the drawing sheet with the drawing pins. Now draw a straight line as shown in the video so that we will get a neat structure of the prism and their angles in a sequence. Let's trace out the outer boundary of the prism as shown. Now draw two parallel lines on the either side of the prism as shown in the video. These lines should be parallel to each other and intersect the sides. Let's mark two points on each line, that is PQ and RS. Let's place the pins first on PQ and find their reflection. So the PQ will be our incident ray, and let's place the prism and check their reflection. So here is our reflection, we can clearly see. Here is our reflection taking place. That is, pins are in a straight line. This is our reflected ray. So we have to join them as shown and extend that line inside the prism so that we will get the angle of prism. So let's name the points as P dash and Q dash. Let's do same for the R and S. First we'll place the pins, then we'll place the prism on the drawing sheet, then find their reflection. So for R and S, we can clearly see the reflection where the pins are straight and they are like coinciding each other. They are like single pin. They should be like single straight line. So we have to place the pins. So we can see that the pins are in straight line. We have to join them as we have done for the PQ and extend them backwards so that we can find the angle of prism. So let's point the points as RS. This is our angle of prism, that is 2A. X, and this is our 2A. So let's take a protractor and find the angle of prism, that is 2A. So now 2A is equal to 122 degrees. We can see that it is 122 degrees. So 2A is equal to 122 degrees. Then our A will be 122 by 2. So angle of prism is equal to 61 degrees. This is our angle of the given prism. So now to determine the angle of minimum deviation, we will draw the same outer boundaries of the same prism. Then we will mark a point on the line, and then we will point our normal, that is our 90 degrees first, and from the 90 we will draw the 30 degrees, that is this point. This is our 30 degrees. So now we will join the lines. Make sure that you draw lines long so that we can point the reflected rays. Now this is our normal. This is our angle of incident, that is our 30 degrees. That is the angle of incidence is equal to 30 degrees. So now similarly, as we have done for the angle of minimum deviation, we will point 2 points on the incident ray, that is our P and Q, and now place the pins on the points P and Q as shown in the video. Make sure that the pins are not bent. We have to place the prism. And now we can see the refracted ray right here. We can clearly see the pins that are in straight line. So this is the point where the pins are in a straight line. So this will be our refracted ray. So we will mark the pins. So this is our refracted ray. No pins are here and there, they are like coinciding each other. So we will join the points. And now extend the incident ray. So basically according to the incident ray, the line should be in this direction. The refraction should be in this direction according to incident, but it is refracted at this line. So we will draw the normal to the refracted ray also. This is our normal and this is our incident ray. So this is points P dash and Q dash. This is our angle of minimum deviation, that is our delta. So we can see here the angle of minimum deviation is 46 degrees. So for the angle of 30 degrees, the refracted angle is 46 degrees. That is our minimum deviation angle is 46 degrees. So this is the way that incident ray refracted. So now let me explain once again. This is our angle of minimum deviation for the angle of incident, 30 degrees. So this is our normal and this is the refracted ray. Now let's draw similar for the angle 35 degrees. First we'll draw the outer boundaries of the prism, then we'll draw the normal, then we'll point the 35 degrees from the normal and place the pins on points P and Q. Then we will see the refracted ray where the pins are refracted. So this is the refracted ray. You can clearly see the lines which is in straight line. Now we will join the points P dash and Q dash. Make sure that you draw this neatly so that we will get the angle of minimum deviation precisely. Now similarly we will extend the incident ray and then we will extend the refracted ray. This is the refracted ray. This is our angle of minimum deviation. So we can see that the angle of minimum deviation is 45 degrees. So for the angle of incidence of 35 degrees, we are getting angle of deviation as 45 degrees. So the first diagram represents the angle of prism and then the other represents the angle of deviation for different angle of incidences. That is 30, 35, 40, 45, 50, 55 and the 60. So here we can observe the angle of deviation for the angle of incidence from 30 degrees to 60 degrees. So now let's look into the graph. Here we can see the angle of deviation decreases and starts increasing at one point. That is our angle of minimum deviation. So for this, the angle of minimum deviation is 41 degrees. So now this is our final result, that is the refractive index of given glass prism is 1.53. So that's all for this video guys. Thank you for watching.